So here we are, summer 2022. Thanks for joining us. Our first portion, our first part of the summer learning series, Developing Number Sense, K-5 with Annalise Record. I've gotten to know Annalise over the last couple of years. There's going to be a lot of content. Hang on. You're going to see a lot of passion. You're going to just see a lot of content. You're going to pay attention. Keep up, because I know Annalise is full of passion and she's full of content, and she is going to give you as much as she can in the remaining, I'm going to say 55 minutes or so. So with that, Annalise, I'm going to turn it over to you and let you do your thing.
Super. Welcome, everyone. I'm so glad to have you here and that you decided to join in on your summertime break to learn about some math and how we can really help our students, every single student, be successful and have positive math journeys. And of course, the main issue and idea, we want to build their math identities, that they know that they can learn math, that they can solve things, they can use what they know to solve what they don't yet know, right? So just that whole major piece that we create those positive journeys for our students. So I have some content for you today of how do we build number sense? So what is underlying our being able to have students be able to have the disposition that when they're asked a question, they don't just rush to calculate, but instead they look at the numbers and kind of have the numbers speak to them of like, what can I do with you? What strategy might I be able to use that uses that number sense to be able to find out an accurate answer more efficiently than some of the possible ways that they're already going to now? Because in moments of stress and anxiety, we go back to what's familiar. So very often students, when they're doing addition or subtraction, will go back to counting. Or if they're multiplication and division, they'll go back to skip counting, which is additive reasoning. And so we want to help facilitate those journeys for every single one of our students. So I just want to just start off by saying welcome, and I should be able to share my screen. Are you sharing? Yeah, I can share my screen now. Thanks, Mark. All righty, so here we go. So are you able to see my screen now, Mark? The PowerPoint. Just want to make sure I'm sharing the right screen.
Yep,
all right,
sure can.
Super. So you'll notice that the title today is Developing Number Sense K-5. It is not just a K2 topic of number sense, because the same things that we do to build number sense, kindergarten through second grade, are the same things to build number sense with fractions and decimals as we continue that journey. In fact, one of the major things that happened for me when I became a math coach, I was a grade 5 teacher for 13 years. Then I became a K-5 math coach. And I had to learn at that point, what was early numeracy all about? How do you teach a child about the number 5? And one of the biggest awakenings for me in that depth of understanding was that it's a connected journey. I was kind of in my silo of grade 5 for a long time. It's a connected journey. The things we can do, K2 can help support the work of 3 to 5, and we're preparing them for the grades of 6 to 8 and that proportional reasoning in the next phases. So just want to be able to share with you just a little bit of the start here, that you can travel the country and work with schools and districts. I do virtual and in-person trainings, but you also can join my email web list, my email list, where you can get information on my consulting, but also I have some free Padlets for information for you. And I have a newsletter that I do once or twice a month that kind of connect you to all the resources that are out there. There are tons of brilliant and kind and generous educators out there that I want to connect you to their resources. They're all free and just for the benefit of helping every child have a positive math journey. So I want to start here. My friend and mentor, Dr. Nikki Newton, always says that math is not a spectator sport. And I love that, right? We want to get our kids and ourselves actively involved in the mathematics. So what I'm going to do is I'm going to be sharing a question for you. In fact, I'm wearing the first question on my shirt about the true or false, whether these two expressions are the same. Remember the equal sign, we want to make sure we're talking about it as the same as. We get a sense of a balance, that the value on the left is the same as the value on the right. And so I want to give you a code. I'm going to do a live share feature. So if you're new to Brainingcamp, they have this fabulous, powerful ability to allow us to watch our students working live. So I want to bring you right to this screen here, this Brainingcamp. This is the beginning one about how can you convince me? So I'm going to want you to convince me the same as 54 minus 40. You can use line. You can use markers to draw and write things as well, or add in some text. What I did was I created a code, and I'll be giving you these share codes today for all the things that I'm doing. So you'll have them moving forward. These codes don't expire as long as you are a member of Brainingcamp. And so I will just be going this, I had that share code all ready to get this on the screen, but now I'm going to do a live feature. So this is our ability to watch students work live. And so I want to just bring up this code here. So this is the code that I'm going to copy that for you right into the chat bar. If you go to Brainingcamp and you sign in, redeem it if you don't have the membership yet. And I want you to put that in the share code box. So you'll notice when you go into Brainingcamp, upper right-hand corner, there'll be a little rectangle that says share, and you want to put that code in the share box. Now, today is kindergarten through 5th grade, and I want to be able to differentiate a little bit to allow those of you in the grades 3 to 5 to also experience the power of this. It should be, Elvira, it should be right in, oh, I think I need to do, thank you, Elvira. Host and panelists only. Oh, I'm not able to, oh, here we go. Here we go. Everyone can see it now. Thank you, Ryan. I did it just to the hosts. They don't need the code. So putting this code right here in that share code, but those of you that are grades 3 to 5, I want you to experience this as well. So I want to show you how I can do a different share code, which is a different expression, still in the number line app. But what I'm going to do is I'm going to load a new code. So I'm going to do load. Those of you that already have your screens up for the 52 minus 38, I want you to get to that point. Everyone needs to get to that point. But if you would like the code for the grade 3 to 5, which would be fractions, subtraction, what I'd like you to do is you have in the bottom of your screen, you have the ability to raise your hand. And so if you click on that raise hand, and change your raise hand to be any color, the red, yellow, or green. And then I'll push out to you the code that is for this fraction example. Those of you that are K2 and want to work on the whole number subtraction, you can go ahead and get going. I'd like you to show me, convince me that these two expressions are the same. And then again, those of you that are in the upper elementary, you want to try out the same thinking, the same activity, but with the fraction subtraction. Again, what you can do is just be able to click on there, make your yourself red or green, and I'm going to push it out to you. So here we go. I'm going to push this new code out to you. You will need to unraise your hand once we get there. So here we go. And I'm going to push that out to you. So you should be having the code for the fraction subtraction. I want to give you a few moments to be able to prove to me, show me with the math tools. You could write in the text, you could write with the markers, whatever tools you want to use in this, and then show me your thinking. Those of you that are joining now, if you'd like the subtraction with the mixed numbers instead of the whole numbers, what you can do is just raise your hand and change your color. And I'll be able to get you the fraction example. So Lori, you mentioned you don't know how to change the color. You should have a button that allows you to raise your hand and then select any of those colors. That's a way that I can push out to you the code for the fractions. Patricia, if you hit an escape key on your computer, you should be able to exit out of the current tab that you're watching and get to a different tab. And so I'm seeing some work here on the number lines. I'm seeing some writing, right, to prove the two are the same. I'm seeing some of those rectangular bars. It looks as if you're showing the distance between the two numbers. I'm seeing some jumps on the number line, and you're using some friendlier numbers. So subtracting 10, subtracting some more. Awesome. So there are those red jumps that allow us to subtract. So we're going to on the left, toward the left of the number line. We also have them in green, which is positive. Super. Thank you so much. So as the teacher, if you come back to the Zoom meeting, you'll be able to see my screen. And so my screen is showing all my view of this. I can see everyone's screen as they're working. I would be able to then bring up someone's screen and give a comment and then push it back down to them. And so if I were just to bring up one here, I can just click on the right three dots and I can load it. And then that will be brought up on my screen of the work here. And so you'll be able to see the different work, be able to then be able to share with the students how these two expressions are equal. And then you can just push that, you can close it, you can push it right back if you wanted to comment on some of people's work. And so I see people are proving, right? So we're going to calculate the 52 minus 38, and we can calculate the 54 minus 40 and show that they both are equal to 14. So they are the same. And I'm just looking for a second. I think I'll bring up, oh, that's a fraction one. Hang on a second. If I bring up this one for you. Oh, nope, that wasn't the one. I wanted to get that whole number one I thought I was grabbing. Well, I'm going to grab this one for you right now, because the thinking actually is the same. I've been giving you examples here that the two expressions, are they the same or are they not? And you can see here that in the fraction version, but again, the thinking is the same. We're building that number sense and thinking about the fact that the distance between the two numbers is staying the same if I add or subtract the same amount to both. And so if I know that and have that number sense built, I can slide that distance along a number line. And there isn't the need then to regroup and think about how many pieces are in each of those holes and go through that whole procedural way of solving aren't successful at doing. And so you can see here that these two expressions here are the same, because the distance is the same. So you may not actually calculate if you're using number sense. It's about relationships and the relationships between the numbers, and understanding fundamentally that one interpretation of subtraction is the distance between the two numbers. And so I gave those numbers that were kind of close to a near whole number so that we could kind of slide it along to show that if these two expressions, and similarly with the one I have on my t-shirt, the 52 minus 38 and the 54 minus 40, if they have the same amount and I have to calculate an answer, which one would you rather think about, right? It can avoid and make the mathematics much more accessible to so many more of our students. So welcome to, I'm going to exit out of the live session now and go over to my presentation for you. And which that about a moment, these strategies that you're using to figure out what these two amounts were the same. Maybe you were calculating the 52 minus the 38 and you're using, I saw some jumps on the number line, but I was seeing jumps of 10s and 2s, thinking about what are some foundational concepts that the student needs to have in place. And so if you can just go ahead and just type in here in the chat bar, and just tell me what kind of fundamental skills do our students need to be able to do this kind of flexible thinking and reasoning and using that number sense. Any things you can narrow down to see? Fundamental skills, place value for sure, understanding the place value, decomposition, absolute position that I can break apart numbers, not only the whole numbers, fractions as well, right? It's the same. The whole number sense journey is going to repeat itself when we introduce fractions. So knowing the difference, right? Understanding the operation of subtraction, that it might mean removal. So it might take things away if there's some action for that. But it also means the distance between the two numbers. And I might even want to use addition. If the numbers are speaking to me that they're kind of close together, I might use addition. So absolutely. So a lot of these things that you're mentioning here, the decomposing, the place value, the understanding of equality, right? The understanding of equality, that means the same as. So I know for myself, many years ago, I would have gone ahead and calculated both sides and ensured myself that they were the same. But I also know now I've been working on my own relational understanding of the numbers. And now before I calculate, I weigh to beat. Now I might calculate, there are some numbers that were given that, yep, I'm going to go ahead and calculate that answer because I can't think of any other flexible, more efficient ways. But I also have other tools in my toolbox that I can weigh to beat, and I can think about those numbers and what strategy works best for you. So how do we build this with our students, with our number sense, right? Our whole numbers. And also I'll be talking today about fractions as well. So thinking about our typical ways, that I saw all the years in my classroom and making math coach as well, do any of these look familiar to you? I had a student talk me through that 14 minus 8 in front of his 25 friends and 10 teachers that were watching as well, right? That sense of, oh my goodness, 14 minus 8, and we regrouped and we still ended up with 14 minus 8, right? That doesn't make any sense, that doesn't have number sense, right? Or the 102 minus 98 is one of my favorite ones to give students as well. They begin the regrouping and then it becomes a nightmare, regrouping across the 0, but yet the distance is just 9. So if we can think to ourselves, well, before I calculate, is there anything else that I can do to help me think through it and make it more efficient for me, right? And then with decimals, my fifth graders, I taught them the procedure of lining up decimal places. But then I knew I'd have a handful of kids who would still put, 1300s. And I would say they have no number sense. But then I didn't do a whole lot to help them build number sense either. I didn't know at the time. I live by the quote by Dr. Maya Angelou that we do the best we can until we know more. And when we know more, we will do better. I love this quote by Christina Tondevold. Number sense can't be taught. It needs to be caught. It's not about us teaching kids strategies, is about us facilitating their journeys to build the understanding themselves. We need to be able to have the students be making sense and constructing their understanding, and we are facilitators of that journey, being aware of where they are in the learning progressions to help them along. So we are all on learning journeys, and I am as well. The more that I learn, the more I realize I have to learn, and that's absolutely true. And so we're just joining this journey, helping our students have positive math journeys, and also for ourselves as we build our own math minds. So I know I've done that myself. I was a very procedural, memorized math student when I was a kid, and I succeeded very well. So I have a very positive emotions when it comes to my childhood journey learning math, because I was successful at doing the rules and procedures. But 80% of the people that I meet in my consulting work across the country, 80% have very negative, traumatic math stories of them learning math. So we need to change this. We want every one of our students to be able to have positive math journeys. So what is number sense? Before we get into some specifics of what we can do, what is number sense, right? So here's my favorite quote by Howden about what number sense is. What I'd love you to do is read it to yourself and then type in some quotes in the chat bar, some phrases that resonate with you of what number sense is. Yeah, see relationships, the relationships between operations, between numbers, sets of numbers as we're operating on them, and the visualization, so crucial for every single brain. It's not that certain people have visual brains. I know that because I did not learn math visually. I thought I didn't have a visual brain. And sure enough, our brains are plastic. They have this ability to grow and change and build new neural pathways. And I've done that in my own brain. I now do see math visually. And in fact, when you give me any kind of question, if it's a middle school problem, I want to enter it in a visual way. It helps my understanding. It builds my confidence. It's not for certain people. It's for every single person, right? So we also want to be building that by exploring numbers, right? Is that students constructing their understanding and relating these contexts, right? But relating them in ways that are not limited to traditional algorithms. The traditional algorithms are robbed of the place value understandings. When a lot of teachers that I work with will say, my students have no place value understanding, I will ask them, when was the first time the algorithms were taught for like adding and subtracting in the K2 journey? And very often it's grade 1 and 2, as opposed to the 4th grade, where it actually is in the core standards, because we want students to have time to build their flexible understanding that include the place value as well. So let's talk a little bit about these. These are Van der Waals' 8 elements of number sense. So we have verbal counting, object counting, cardinality, subitizing, spatial sense, knowing one more, one less for numbers without having to count on or count back, benchmarks of 5 and 10, but also in the upper elementary world, half and whole, 5/10 and a whole for decimals as well. And then that part whole, that decomposition. So I want to focus in today on 4 of these elements of number sense, but kindergarten through 5th grade. I want to show you the application of 4 of these: verbal counting, subitizing, benchmarks of 5 and 10, and half and whole, and then the decomposition, to show you this trajectory, how we can connect what we're doing with our K2 students with our 3-5. That is that connected journey and what we can do to play that part. So the very first thing I want to talk to you about is the verbal counting. So when you think about students entering kindergarten, very often they know the ABC song, right? So they know the song that gives them these letters, but they don't yet know what letters look like as a symbol. They don't know that they have sounds attached to them, right? Similarly with the mathematics, we want the students to have the words, that lexical entry into their brain of the words of the numbers in the correct counting order. So certainly we've always done counting activities in our classrooms, right? We need everyone doing counting, not just our kindergartners. We need everyone K-5 counting, because we can also count by fractions and decimals. It gets the words in their brain, but we then can attach the quantitative understanding of what those numbers are, the abstract symbols for them, right? So I love this. This is a wonderful book called Carol Counting and Counting Collections. You notice the cover says it's appropriate for pre-K to grade 5. This is not an early elementary topic. Both of these activities are so powerful for all grade levels. But I'm focusing on the choral counting, where the way the routine works is we all count as a chorus. It's not one student doing the next number in the sequence. We all count together. We are going to be, as teachers, writing the numbers down and then having the students look for patterns. So it's not just getting the words into the minds of the students, but looking for patterns. Math is all about finding patterns with numbers and shapes. So I want to share with you, this is the link to the share codes that I'm doing today. So if you're new to Brainingcamp, they have the incredible power of having these share codes where you can type in you can put whatever you want, any app that you want, as well as any of the items on the screen. You can create a task for the students. And then you can share that code with your students, and then they can begin working already having that on their screen. So this is going to make you make a copy. So that is you're going to have your own document of these share codes. It's going to look like, it's going to ask you, you want to make a copy of it, and you'll get a copy of this document. So the share codes I'm using today to facilitate this session, you'll be able to go right to that link and be able to get your own copy. Then you can add more codes as you go, because again, these do not expire. And so I'm just going to be using this to be able to facilitate the time today. So it saves some time, right? Being able to have that already on the screen. So I'm going to just go back to the main Brainingcamp screen, upper right-hand corner. That's where those share codes go. So I'll just paste that in. When I say go, it brings me into the app I had been in when I grabbed that share code. So you want to put whatever you want on the screen. Then what you do is click this button right here, it says share, and you click on that share code. Okay, so that share code then generates about an 8-digit code, letters or numbers. Actually, I believe maybe just be numbers, letters. And when you put that code in that share box, it's going to bring you into the screen here. So here would be an example of this choral counting. We want to be able to count with our students, right? And being able to mark down the numbers as we're counting. But you have flexibility of knowing where you want the one to be. Do you want it in the upper left-hand corner, bottom left-hand corner? Do you want to go left to right? Do you want to write the numbers going down? And how many do you want in each row and column? So you think about that all ahead of time to think about what patterns the students might be noticing. And so as the students are counting, right, we can be able to even mark it off. You can use these colors as well. So as we're going and we're saying the numbers, you can keep going here, right? And then when we're done, you decide what number you want to start on and what number you want to end on. And you also could think about how many rows and columns. And I would suggest you do that ahead of time. There's a wonderful, Stenhouse is the publisher of the book, and they have a wonderful choral counting tool that allows you to enter in what number to begin on, what the interval would be, because this is going to graduate to skip counting as well. And so as you're doing that, what I would love you to do is seeing this pattern here. What patterns are you seeing? Can you type in the chat bar? What are some patterns that you see? So as you would be writing these numbers on the board, after you said them all and everyone is counting all together like a chorus, what patterns do you see? So it's counting by one. So going from left to right, it's going up by one. Awesome. So it's adding one, increasing by one is that interval. And then as the teacher, I would be then writing in the observation. So it's going, it's counting by one. And then I would just slide that off to the side. What are the things that you're noticing? Oh, it's by 10. So perhaps looking down the columns, it's 10 more than the one above it. I see. So counting by one, I might mark that like this. And in fact, we've been doing, we can color code things. So what if I do this in blue and I just like draw an arrow, right? It's going up by one. And then I can make this text box also be blue. So it matches the same color. So our blue text is matching my blue marker. Well, someone also noticed that it goes up by tens. So it is going up by increasing by 10, going down. And I can change that color. I'll make that red. And then what we can do is we can be marking that same color we noticed that pattern with. I can change my marker to be red. And it's going down like this, right? Each new line is going up by 10. And so this activity, again, can be repeated with all sets of numbers. And it's also that you can start with numbers that maybe aren't one. So let me just show you for a second. I'm going to go back to the share codes here for a second. And I'm going to use the, what if we did skip counting by fives? Let's see what happens when we do this. So with this share code here, and again, all these share codes are in that document for you. So notice here, I changed the numbers to be in the 400s. And here we're starting on 407, but we're going to go up by 5. So students might begin by saying, well, to go up 5, we could go 3 more to get to 410, and then 2 more would get us to the 412. There's where our decomposition comes into place. We can break apart our numbers. So rather than counting one by one, we want to help the students move into additive reasoning by going, let's say, to a nearest 10. So I have to know that 7 and 3 make a 10, right? So 407 plus 3 more makes the nearest 10. And then I have to know that in that 5, it takes 2 more, that a 5 can be a 3 and a 2. So I've landed on this 412. Well, what would be 5 more than that? Well, 412 plus 5 would be 417. And then think 5 more is going to be, well, here, right? And at this point, now we're having patterns, right? We're having just these numbers here. So as you are writing this on the board, again, we're writing the numbers and then having the students notice the patterns that are happening, right? The ones place is always having a 2 in it and also a 7. And then our tens place is increasing by 1. It's getting 10 more. And they might notice that some of the the 400s are staying the same, but then occasionally it changes as well. So it's about the students noticing these patterns rather than us telling them those patterns. It's a very different mindset in our math classrooms, rather than us being the ones that are imparting, this is how you do the math skills. We want to provide opportunities for the students to construct their understanding and have them be understands and that. So that is some verbal counting, right? Getting the verbal count into their minds. And then, but also I want to show that connection in grade 3 to 5, that we have the same thing happening with our decimals. So if we're having this example here, we can also change our hundreds chart to be with decimals. So you can start on any number. This is an example where I have the 200ths and we're counting by 200ths. And I chose, we have these 5 going across in a row here. You're watching patterns emerging down here. You also can use it to predict. So you can be thinking about what number might appear beneath this one, right? So it's allowing us to be able to have those underlying patterns within our work with our students, being able to have that pattern happening for us. I also just want to show you one more thing with the hundreds chart, that it's also wonderful to be able to have the ability to, again, focusing on the patterns, that you can be having a board like this. This is down in the middle of the screen. What I did here was I did this box that allows these question marks so that random ones are appearing on the screen. So you can ask the students, okay, what number would be appearing here? And then ask them, how do you know? What's the pattern that you're seeing? When you click on that box, the number actually will appear. You can turn that and toggle it on and off. So a variety of things there. Again, we want students counting to be able to get them the lexical entry in their brain of these words, not only with the whole numbers, but we want to repeat it all over again, starting in grade 3 by fractional amounts and decimal amounts. And I would also encourage with the fractions, you're doing it in the fractions greater than 1, right? We don't want to call them improper fractions because im prefix makes it sound like it's not okay. We want to call them just fractions. Just turns out they're fraction form. Some of them are greater than 1. And then the mixed number form as well. So students can be able to see that connection there. So that is verbal counting, super important. We get all the kids counting, as well as I want to move on now to the subitizing. So subitizing is a word I had not heard of as a 5th grade teacher. I hadn't heard of subitizing before, but it turns out that subitizing is totally appropriate for upper elementary as well. So what is subitizing? It is the ability to tell at a glance how many are there without having to count. I'm currently reading Kathy Fosno's book, Conferring with Young Mathematicians, and she mentioned in there the research that infants, when shown 3 objects, if you take one of them away and show them the 2, they will look for the third one. Now, they are not counting yet. They are infants, but there's an innate sense for us of subitizing, telling how many are there with a glance. And so the subitizing is telling at a glance how many are there without going one by one. So if I were to show you some dots here, could you just determine how many do you think are there and how are you seeing it? So here are some dots. And then, how many do you think were there? And would you bet me a pizza on it? So I'm seeing possibly some 8. Yes, and I would imagine for you to figure out that there were 8, you couldn't count one by one. I did it as a quick look image. So our mind will look for the groups of objects within it. So with subitizing, our brain can tell at a glance how many are there, even as adults, only up to about 5 scattered objects. Other than that, we look for groupings that we can subitize and put those groups together. And so we also can do a benefit for students by doing subitizing with them where we've organized it into patterns so that our brains can tell, oh, I'm familiar with that. That's 5. I played enough dice games that's a 5 dot pattern, a 5 and a 3. And I can now figure out what 5 and 3 are all together. But that scattered amount, we really can't tell as adults, more than 5. So our brain will look for the subgroups. So that is subitizing. How does that help us? That's going to help move our students from the counting phase of reasoning into additive reasoning. And so if we just go to here, I'm going to show you subitizing, how that can also be happening here. So Let me go back to our share code. So if I were to show you this amount here, it isn't like a dice pattern, but how many dots is that? And how do you know? So we want to build that as a skill for our students to recognize amounts up to 5, being able to tell without having to count. I know that it's 3. I've developed an understanding that that is a quantity of 3. What if I have dots like this, right? Typically we see the 4 like a dice pattern, but what if I do things like this where I'm seeing it as a 3 and a 1? This is supporting our decomposition of numbers. Having our students build to know all the pairs of numbers that make all the numbers up to 10, that's going to help us. It's embedded within the work of our multi-digit work and decimals and fractions as well. So we want to have these images, having them familiar with these images that allow them to build that visual sense of the decomposition of numbers. And let's do one like this too. You can do supertizing activities using math tools. And we ask the students, how many are there and how are you seeing it? Now we've got to give an opportunity for the students to share how they see it because and how they figured it out. We want to be aware of the learning trajectories of the students beginning an accounting phase of reasoning. So students might count those yellow dots one by one. It tells us they're in accounting all phase of reasoning. When they then begin the next level of understanding, they will count on. So I can start with the 3 and count on the 4 more. But other students are going to recognize that, oh, I can begin with the 4 and count on the 3. The fundamental concept of the property of the commutative property of addition allows us to change the order. So it's going to be easier for our brain to start with the larger number and count on. But all that sophistication is happening in the world of kindergarten, right? But in grade 1, we want to help move them into some additive reasoning, which is going away from the counting. So perhaps someone might say, well, I can see that this 3 and 3 is 6. And so 1 more is 7. So a 3 plus a 4, we might think of it as being related to doubles and doubles plus 1. 3 and 3 is 6. So if I know 3 and 3 is 6, I can figure out for you 3 plus 4. It's just going to be 1 more. Maybe I prefer to think about 4 and 4 being 8. And so 4 and 3 is 1 less than that, right? Or maybe I see, well, this whole tool that looks like it's using a benchmark of 5 and 10, and there's no accident about that, it's missing 3 of them. So what if I know 7 and 3 make a 10, and I'm supertizing, I'm telling that 3 of them are empty, so it must be 7, and I didn't have to count, right? So all that thinking is our hope to generate with our students in that additive phase of reasoning in grades 1 and 2. Now, let me show you how this happens to get now as we work into grade 3 to 5. Now, in 2 different realms, I want to show you the multiplication application of supertizing. We want to help our students in the multiplicative reasoning to go beyond the skip counting. So skip counting is, that memorizing the multiples of it, right? But it also then graduates to repeated addition, where I know it's adding each group over and over again. So with that, we want to help move our students into understanding that there are groups of groups that we can use. So here we have the familiar structure of a 10 frame. And you'll notice what I did. I put dot patterns in each of the boxes. So if our students are familiar K2 with a 10 frame, we can then graduate that in grade 3 of using multiples. Well, what do you know? You might not know yet that 7 times 5 is 35. So important. What is the thinking if you don't know it? What is the thinking? Is it going back to what's familiar by counting 1 by 1? Is it what's familiar of skip counting by 5s? Or is it saying, oh, 5 5s is 25. I've learned that one. And then 2 more 5s is just 10 more. So it must be 35. Or what if I give an array like this? And I ask the students, how many are there? Maybe when they see this, they're thinking, well, rather than counting 1 by 1, do I know 2 6s? Well, if I know that 2 6s are 12, then how much more do I have to, oops, I don't want the red. How much more do I have to go to figure out 4 6s? Oh, there's a relationship between doubles that times 4 groups is double the 2 groups, and 8 groups is double the 4 groups. All of this is embedded within this number sense, right? The number sense that we're building with our students to understand the operations and understanding our working flexibly with the numbers, right? Not doing the algorithms which rob it of the place value understanding too soon in their journeys, right? We want to give them this time to build these neural pathways and understand the numbers and build this in this way. Here's an example of supertizing with fractional amounts. I'd love you to look at that and see how much of that the entire rectangle as a whole. So how much is shaded? Yeah, I see you're seeing half, right? I know in my 5th grade classroom with fractions, I rarely, if ever, got in front of the students images where there were different shapes within it. We partitioned, circles and rectangles vertically and horizontally. I know I did some diagonally, but it was all the same shape inside that hole, right? So here's that understanding that building the number sense of fractions is that we need to think about the area that is covered with it and what is the part of this entire thing, right? And yeah, 4/8 or 1/2 of that is shaded. So supertizing is not just for the young kids. It is also within our realm for multiplication, helping build our distributive property of multiplication, as well with fractions, fractional understanding as well. All right, now let's go on to the benchmark of 5 and 10. So let's go ahead and here. Grab the wrong code, so sorry. Benchmark of 5 and 10. So one of my favorite things, a lot of my work has been on fact fluency. I believe that the beginning of everything, the foundation for all of this can be done with basic facts, and then we extend them to the larger numbers, decimals, and fractions. The same thinking strategies gets extended. And so if we do, these are what are called math flips. So Berkeley Everett has a wonderful site on that document I share with you with the share codes. At the bottom is a link to Berkeley Everett's Math Flips site. But here is 10 frames, right? So we asked the children, how many are there and how do you know? Now they might start with 6 and count on 6 more, but are there any groups of amounts within it that you know? And students might say, well, I know 5 and 5 is 10. So that ability to break apart numbers and put them back together in ways that are efficient for our brain is so crucial. I can think about 6 and 6 as being, well, 5 and 5 is 10, and then 2 more is 12, right? Well, if I've done that thinking, how does knowing that this is 12 help me solve this? And so Berkeley Everett has tons of these for different strategy sets within all the 4 operations. That it's always that connection, the conversation. How does knowing what's on side A help me solve side B? How does knowing 6 and 6 is 12 help me solve 6 plus 7? That's going to help us move the kids from that counting phase of reasoning into the additive reasoning. What if I do something like this? What if we think about the structure again, 5 and 10. So here we have an image of 4 10 frames, and there are 5 on each. So if the entire image was filled in, we'd have 4 groups of 10. Right? But visually, we can see now we've got 4 groups of 5, which is half of that. So there's a relationship between 5 and 10. 5 groups is half of 10 groups. In my 5th grade classroom, my students skip counted by 5s a lot, and I didn't know what else to do other than having them using a benchmark multiple, like 5 and 5 times 5 is 25, and skip count from there. But what if we explore 5 groups is half of 10 groups? Let's think about 5 times 8. This is what's called a number string. I'm going to do some examples here that all use the same strategy to help see that application. 5 times 8, well, if 10 times 8 is 80, 5 times 8 must be half that, 40. What if I do this one? 5 times 16. The pattern of our number system being a base 10 number system, we don't want to say we add a 0. That's not, that rule will expire when they multiply decimals. Instead, we want to talk about in grade 3 that 10 times 16 is 10 16s, and that number is 160. In grade 4 and 5, it graduates to a shifting place value position, that each of those digits is becoming 10 times greater. So 16 is going 10 times greater. It's going to become 160. And so what is half of that? What's half of 160? It's 80. And that actually is what 5 times 16 is. So it's one way of many to derive what that fact is, right? But thinking about 5 being half of 10, this has changed my life. 5 groups being half of 10 groups, I use all of the time as I'm doing middle school math, mental math. I do a thing called Pam Harris. I love her site, mathisfigureoutable.com. And every Wednesday she does a math strat chat. I've been doing it for years. I built the flexibility in my own brain with upper elementary, middle school as well. Look at this, 5 times 246. What's 10 times 246? Shifting place value position, right? 2,460. And what's half that? 1,230. So many more of our students can attain that. And I know I hear from people that they don't know their math facts, so they can't do these computations. I push back on that. We can derive our information when we have that disposition that we can use what we know and use relationships to help us. One last one here. How about 5 times 4 and 8/10? Becomes a nightmare when we're doing the procedural, pretend it's not there, then count in that number of decimals. Tell you what, decimals never move. It's the digits that are shifting place value position. I'm going to repeat that. Decimals never move. When we are multiplying with decimals and dividing decimals, we don't move the decimals. It's the digits shifting place value position and the relationships with the place value. Let's talk this through. 4 and 8/10 times 10, shifting place is 48. 5 groups must be half that, is 24. And I've eliminated the thinking. Too often our students will do the algorithm, but in the algorithm for basic facts, they are skip counting. So they're doing additive reasoning, even though it's a multiplication with decimals problem, right? It connects all the way through. I have one last thing for us to do, which is about decomposition. Decomposing, you cannot do enough of it. We want all of our students to know all the pairs of numbers that make up all the numbers up to 10. And then in grade 4, we do it all over again with fractions. We want to be able to break apart fractions into all the pairs of amounts so that we can embed that in our work when we're doing adding and subtracting and getting to the nearest whole number, similar to like an 8 plus a 5, to know that 8 plus 5, well, it's 2 more to get to 10 and 3 more to get to the 13. Same thing will happen with 4/5 plus 3/5. It's 1 more fifth to get to the next whole, right? And then I have to know that in that 3/5, there's a 1/5 and a 2/5. So I want to give you a chance here of my favorite manipulatives Cuisenaire rods. I have an online workshop on my webpage on Cuisenaire rods. They're the key, I feel, to move our students from counting into additive reasoning and additive into multiplicative and even in proportional in grade 6 to 8. And so I'm going to start a live share code here. I want you to break apart. So here's the context for it. On a table, there are apples and oranges, and there are 6 pieces of fruit. So what are all the possibilities? And I would encourage you to think through as you're doing this. So here's this code. I'll copy that into the chat bar for you. Think through the possibilities of what apples and oranges could be. But I also would encourage you to think about, how do you know you found all the possibilities? Have you done it in a way that allows you to know all the possibilities and you have confidence that you have found them all? Now, similarly, those of you that are in grade 3 to 5, I want you to experience doing this with fractional amounts. And so once again, I would ask for you to raise your hand. So you join the live session using the code that I just gave you. You then raise your hand and I can push out to you the code that would allow you to do this decomposition with fractions. This is a grade 4 standard. I put it in the context of fabric being in pieces of 1/8 pieces, and we're breaking it apart into all the pairs of numbers that make up that fraction. This is going to allow us to build the flexible thinking and the number sense, so that we can be using number sense strategies when we are doing calculations with numbers. We're not limited to algorithms and procedures. Too many of our students are locked out of the math journey. They begin thinking that they are not math people, that they don't feel welcome in the classroom. We've got to help build safe math communities that allowed every student to understand that they can use what they know to connect with these relationships to figure out ones they don't yet know. I'm getting some more of you here with the pushing out the codes. Oh, I see you're working. Okay. And so I'm just looking to see, right? There's definitely a place for students to be randomly choosing the pairs that make up a total amount, whether it's whole numbers or whether it is fractions and decimal amounts. But that flexibility is going to allow them to have that break apart the numbers so we can be reassociating them in ways easier for our brain. We definitely need this as well in multiplication and division. So when I'm breaking apart a factor, I interview a lot of students, thousands of them, with math running records. Dr. Nikki Newton's invention of the math running record, just a codification of the research on how we can talk to kids about their thinking. And in talking to the kids, getting them thinking about what they're doing, being aware of where they are on that trajectory of, are they counting? Are they skip counting for multiplication? So important. And so when we ask them in the disposition part of the interview, which ones of these today look tricky? Inevitably, any problem that has a 7, kids find tricky. But if we give them strategies to work with a 7, for example, if I multiply by a 7, it's hard to skip count by 7s, right? What if I think about breaking apart that 7 into 5 groups and 2 groups? Can students more easily figure out 5 times the number and then a double of the number and add those 2 partial products together? Right? Allowing that flexibility and not going back to skip counting by 7. So they're going to be error prone. They're going to slow themselves way down. Exploring that fact fluency will then again help unlock so many more of the strategies here. Super. And I'm going to be bringing up on the screen for you one example here. I'm going to be bringing up an example for you. So those of you that maybe perhaps are not doing this right now, or if you are doing it right now, we're coming to the end of our session. So I'd ask you to come back to our main Zoom screen so you can see what my screen is looking like. And I'm going to load someone's work to kind of show to the class that there are 6 pieces of fruit on the table. If there can only be apples and oranges, what are all the possibilities? When we not do it randomly, but do it like this, you can see a pattern emerging, right? That this 6 went to 5, 4, 3, 2, 1, 0. And this one's the upside down staircase. This is also talking about the equality of that relational thinking. As one add-in becomes one less, the other one gets one more. I interviewed a student with the math running record, and I asked this first grader what 4 plus 7 was. And she said, 11. I said, great. How do you know? Well, I know 5 plus 6 is 11. And I thought she hadn't heard me right. And but I asked you 4 plus 7. So yeah, I took one from that 7 and gave it to the 4 and made it 5 plus 6. Because I know that is an 11, right? Crazy powerful, right? This relational thinking. I did not grow up learning that way. So I'm building my own neural pathways of doing that. But oh my gosh, that's the kind of creation of young mathematicians we can be creating in our classrooms. And I just want to show you another example here because it's in the world of fractions. The same thing. It's a parallel journey. Number sense is about building that intuition about numbers based on relationships. And remember, and there are these 8 elements we can attend to. All 8 are appropriate for the basic whole numbers, but also fractions and decimals as well. So you can see, again, patterns are emerging here. It'll unlock the door for so many more of our students to be successful with math and build positive math identities, which is so crucial because the jobs we have and that there are current students are going to have in the future, many of those jobs haven't even been created yet. And so many of them include mathematics and STEM and science things, right? We want in technology. We want them to be included and have those as options for them as they're going through their math journey. So thank you so much for joining in today. Such a treat to be able to join with you and share a few of the number sense ways we can work with our students to help them build that sense. And again, to build that disposition where they don't just calculate, they look at the numbers, let them speak to them and say, okay, what can I do with you? And they'll have that positive identity.